Alright, so we looked at permutations, which is how many sets of things we could do where order mattered, where I needed this particular order was one distinct thing. But what if I talked about like my favorite colors, right? Blue, red, and orange. Well, if I wasn't categorizing them, red, blue, and orange would be the same thing. And so would red, orange, and blue, and so on and so on. And so out of all possible colors, these are the same thing. And so what we're going to bring up is a new term called combination. And so combinations are given a list of items. Combinations are the distinct groups that can be formed where order does not matter. And it's the fact that order does not matter that makes combinations work. In fact, I want to show you the formula for them. Your book kind of gives a nice way of showing it, but and notice dot around this in red. This bit here is the thing for permutations. It's the formula for permutations divided by r factorial. And what happens is r factorial is the number of ways. Notice that these three objects that I kept doing, there would have been 6 permutations of those. It's how many ways the things I chose could reappear, and we have to divide out the repetitions, or divide out the repetition. And so let's look at an example. So in poker, a person is dealt 5 cards from a deck of 52 cards. The order doesn't matter. So how many possible patterns can they have? Right? So you get 5 cards and the order doesn't matter. So you're going to have 52 factorial over 52 minus 5 factorial divided by 5 factorial, or 2,598,960. Wait, how did I get that so quick? Well, let's come over here and look at how our calculator does it. And so let's get over to my calculator, turn it back on. And so I had 52 cards. And I'm going to do combination. So a second in math. Oops, not second in math. I'll type in 52 math over to probability and down to NCR for my combinations. And I want 5 cards. And there I get the 2,598,960. And so that's how many possible cards I can be dealt in poker. Again, large number from a small number of cards. And I think this is the part that makes, and I'm emphasizing this in video after video, of how the number of possibilities rise so quickly, and this is what makes it non-intuitive. For example, let's say I have 14 books, and I figure I can read about 4 on vacation. So how many options do I have? Now the order doesn't matter. So I have 14 books, and I'm going to choose 4. So I have 14 factorial over 14 minus 4 factorial times 4 factorial. Oops, I'm looking at this here. I meant to bring it back here, right? So I have 14 books, and I'm taking 4 on vacation. So I'm going to have 14 combinations 4, or 14 choose 4. So that's 14 factorial divided by 14 minus 4 factorial, or 4 factorial. Now we'll go back to the calculator. And so 14 math, probability NCR 4, and I have 1,001 different ways I can choose from those 14 books. 1,001 ways, and so I equals 1,001. 4 books out of 14. 1,001 ways I can choose them. And this, I think, is the thing that makes this study nice, is we can find ways of calculating this out, and we can find ways of making this have meaning. But to realize that in our gut instinct, we don't have a handle on these size of numbers. And so we have to use our math to help us. And so that's combinations. And so between permutations and combinations, we can now count large quantities of things. And what's going to happen is that counting helps us do probability. And that's where we're going from here.